Yeah.
I am Anusua Trivedi. I'm a senior data scientist in Microsoft. I work for AI for Good team. And today I will be talking a little bit about the transfer learning NLP. I will cut down a little bit because of the time that we lost so that the other speakers can also get some time. Okay, so why transfer learning now, right? So we have been talking about transfer learning, and we know that the way that in which we can actually transfer the knowledge from a learned process to another unlearned process can help to jumpstart any project. For example, in computer vision, that is a very, very known fact. So why can't we apply this to text? And that actually triggered a lot of research. So transfer learning for NLP is not as straightforward as in computer vision. It needs universality features. However, simple transfer through the word embeddings is possible. History of research for task-specific transfers, example, sentiment analysis, POS tagging, unstructured sentiment words, etc., are easily possible. So one example that we'll be taking today is about machine reading comprehension, which is still very much in the research phase. To explain a little bit more about machine reading comprehension, it's basically where you teach a computer to read and infer like a human being. For example, if you're teaching your kid to read and write and understand context, that's exactly the similar logic used to train these machines. There are three different types of machine reading comprehension. So one is extraction, where you are actually learning from a context and extracting the information from that context. There's synthesis and generation, where you're learning from a context and generating your own inference. And reasoning and inference, where you are reading a context and trying to infer your understanding from that context. So you're not generating new content, but you're generating your understanding about the content. For example, right, we have a passage like this, right? And I am asking a question. If it just goes and extracts the answer from the passage, then it's just answer extraction. We have a passage, we have multiple passages, and we're trying to ask a question. The answer might be spanning over multiple paragraphs. So there we are trying to understand both the paragraphs and trying to combine and create a new sentence which gives us a correct answer. Reasoning and inference is where you are trying to ask a understanding-based question, like a why, which, those type of questions. So rather than just extracting a line from the passage, you're trying to generate an understanding that you're having from that particular passage. Most of the work of machine reading comprehension actually spans around extraction. So there are two big portions where under which I can actually separate my research. So one is text transfer learning, another is fine-tuning. Fine-tuning is where you're retraining your machine reading comprehension models on your content. So today I will not be covering that. I'll be covering that during the conference. But for the transfer learning part, as you can see, I have 6 different algorithms. Microsoft Research have been working on these algorithms for a very long time. Apart from that, Allen AI Brain Institute in Seattle, and we partner quite a lot with them, have been working, in fact, have been in the forefront of bringing all the research out. So in collaboration with these 2 research labs, we have been able to come up with all the latest and the greatest ways in which you can actually teach a machine how to answer a question correctly. Okay, so for example, you can have documents and question answer pairs. You do not need to train your own models. You take pre-trained models and you just apply your documents and the question answer pairs to your trained model. All it does, it takes the new content. For example, I have a pre-trained model on a very, very generic data set, but I want to start predicting or answering questions about insurance or something about healthcare, something about legal documents, where domain knowledge expertise is needed, but I do not have I do not need to train the whole model. All I need to supply is with some sample question answer pairs and some documents. The model will try to relearn and the context of the content that you are trying to provide, and they will try to generate answers correctly when you ask questions to this newly transfer learned model. For example, right, when you are doing a search, you can ask why is it different from a search, right? When you're doing a search, you are trying to say, okay, when and where is Super Bowl happening? When you ask such a question, it gives you the whole, like Super Bowl 50 is set to take place in Sunday, February 6th. So it gives you a whole paragraph. But when you ask a question to a machine reading comprehension, it tries to give you a very, very specific answer. So when you say in what city did Super Bowl 50 take place in, it will just go and highlight or extract the red bounding box area. That is, it will say that the answer will be in Bay Area. Okay, so that is the difference between a common search and machine reading comprehension. For example, when you're designing a chatbot, you have a context like this, right? How can you automatically generate a chatbot for this? So when you go, your chatbot can ask, what is your number? When you give your number, so if the customer is asking, how can I pay? Then the bot can go and extract that information with your credit card, right? So all this information that the bot is like Charlie, the name is Charlie. So basically all the information that the bot is spitting out based out of this paragraph that you are seeing. Another big example is basically when you have a web page and you're trying to create a bot out of it, the machine reading comprehension can automatically go and extract information from your web page. For example, if you have Amazon.com web page and you're trying to create a bot which tries to give you information from that web page for example, Microsoft Surface Pro, it will, if you start asking questions, it will try to get all this information out to you. So with that, I'll leave it. This was just a teaser, and thank you for your interest. I hope to see you all in the conference. With that, I'll hand it over to moderator for the next speakers. Thanks.
All right. So I'll be talking about how we can predict hybrid cloud capacity with regression models and steady state metrics, generally for all applications which are deployed in the cloud. So what do I do? So I work for Walmart Labs, and my job is to essentially break everything everywhere. Wherever there are applications running in the cloud for Walmart, my job is to break everything and make sure that everything works perfectly and all the bugs are found before things go to production. And to that end, my team builds a host of tools which other application teams use for performance testing, stress testing, functional testing, resiliency testing, and chaos engineering. So that is what I do at Walmart. Now, this talk is focused on understanding how to manage hybrid cloud capacity at scale and how to optimize the cost without degrading the performance of the application itself. And what are the challenges involved in doing so? And what are the steps we take at Walmart to tackle these, and how that can be applied to other organizations as well? And who should essentially attend this talk? It is mainly meant for everybody who does DevOps, also all of the DevOps personnels, all of the app developers, because the kind of capacity which an application gets in the cloud is very important to the app developers themselves. All of the telemetry folks, because they trigger all of the auto scaling functionality based on all of the metrics which has been collected, and pretty much everybody in between, including managers and all of the people who decide on the costing of all the applications which go to the cloud. So this kind of is targeting everybody end to end, and we'll look at how Walmart works today, right? So at Walmart Labs, we have thousands of engineers who work under different technology pillars and develop both front-end and back-end applications, which create the foundation of Walmart's success, both in brick and mortar as well as e-commerce. It might be surprising to some, but the amount of technology which goes into managing all of our brick and mortars, which are spread across US, and all of the supply chain technology which goes behind that is huge, and which may not be very apparent to everybody. And so these applications essentially translate into thousands of microservices which get deployed in Walmart's hybrid cloud environment. By hybrid cloud, we mean that Walmart also owns our own private data centers, which kind of creates the majority of the computes where we deploy our applications. And we also deploy our applications presently in Azure cloud environments as well. So that's what I mean by Walmart's hybrid cloud environment. And these eventually translate into thousands of compute cores, right? Now, when you have hundreds of thousands of compute cores, just the amount of complexity which goes into managing those cores and the costing for those cores is immense, right? And that particular reason essentially warrants a capacity management tool which can both help in forecasting the capacity needed to sustain the increasingly growing online traffic, and also to auto scale the computes based on the current and historic traffic patterns, which will essentially translate into cost savings. Right? So what were the basic challenges which we faced while we do our daily operations, right? So the first thing is predicting how much capacity is needed to even run the current business, right? How much load is going to come on your current systems, whether the amount of computes that are in production are enough to handle the traffic which is coming in, and also to predict how much capacity will be needed to support a traffic which is growing at 40% per quarter for Walmart e-commerce business, and also at about 4% for the amount of people which are walking into the stores, right? And how can we optimize the cost by scaling the computes both in real time and also in a scheduled manner based on the varying traffic patterns? So these are our major challenges, and we are trying to solve these problems. And our answer to that was Thanos. This is our internal code name of our capacity management tool, and it's very apparent from the name. We want to cut down everything to half, right, as much as possible. So we want to cut down the number of compute cores which are used for any given application. To that end, we need to make sure that the application itself is performant, and we have done enough performance benchmarking on the application to make sure that they themselves give the best performance with the least amount of compute. Secondly, we also want to find out where there are excess cores being used at different points in time where there is not enough traffic going into the computes, in which case we can scale them down, saving cost again. So the highlights of my talk on the 24th of April will be around how at Walmart we do performance testing as part of our CI/CD pipeline. So we make sure that all of the applications which get built get performance tested as part of their continuous integration and continuous deployment pipeline. And how do we capture and store all of the relevant metrics both in both the VM as well as the app metrics at scale? How do we efficiently calculate and store all of the aggregated metrics, which we then use for our prediction, inference, and training models? And how do we use real-time metrics to perform auto-scaling on computes in the cloud, both private and public clouds? And how do we choose the best compute flavor for different application profiles? So application could be CPU heavy, memory heavy, network heavy, and depending upon the type of traffic they receive at different times, we compute the right flavor sizes for those applications. And last but not the least, how to optimize cost using all of the above and save dollars. So that is the primary goal. So how to get the best performance with the least amount of money spent. So that's all I have right now, and I would encourage everybody from app developers to DevOps personnel and everyone in between to attend this talk where I'll deep dive into each of these topics, and would love to hear how you guys tackle these similar problems in your organization. So I'll hand back to the moderators now.
To AI first. Please go ahead.
Thank you. Can you see my screen?
Yeah, very good.
Awesome. So I'm going to talk about Google's journey to AI first. I work for Google, and my basic job is to run AI projects within Google. I work with customers to build AI solutions, have a number of small teams to execute on that. So very exciting. I see a wide variety of AI problems. So I'm not going to talk about any one or two particular topics. I'm going to generally talk about the whole journey that Google took from data to mobile to AI. So the main topics in my agenda will be AI at Google. Then we'll discuss a few advanced techniques, such as different modeling techniques, ML models that we use, and what is the how much of that has been accepted by the industry or deployed in various sections of the different industrial verticals. And then we'll take a few key industrial verticals and we'll talk about ML applications within those verticals, like finance, like manufacturing, like energy. So retail is a big one for us. So we'll talk about all of those. So regarding the AI portion, we are trying to build a general AI where data is the new oil and AI is the new revolution, which is going to solve a large number of industry problems, business critical problems for us. We are going to generally talk about a framework in which we do AI. We are very metrics-driven companies, so I like to discuss the high level, how you set up an AI application and how you run the application. Obviously, one of the areas of great expertise and differentiation for Google is deep learning. So we'll go through some of the advanced topics of deep learning, and Geoffrey Hinton, who is considered the father of modern AI, is also a Googler. So there's a lot of research that has been done within his team, and also Google research and Google Brain. Just to discuss a simple use case, we run AI in our data centers. In order to do energy management. So as the curve at the top shows, that as soon as you start a ML algorithm, then the energy consumption drops drastically. When you turn it off, then the energy consumption goes up. So it certainly manages our servers with AI. So that's a very important application that we have within us. So within Google, there are at least 20 different applications that has AI that is publicly known, and probably hundreds that are not known. There are 9 major applications that has over 1 billion users, like Google Maps, like Android, PlayStation, Google Drive is fast approaching that number. So all of YouTube is another one that has obviously search has over 1 billion users. So all of these are run by AI and machine learning. So I'll talk at a high level on Google's leadership. Then next we'll discuss some of the advanced topics that is publicly available for Google. So obviously we started from data, then we went to mobile, and then to AI. So Google has been doing a lot of data work for a long time. And many of those were internal projects that has been made into open source and eventually moved to the Google Cloud platform, which is where I work. Like BigQuery is a data warehousing technology that came from Bigtable REML, which has been there in Google back in the 2000s and has been made into a Google Cloud component recently, PubSub, Dataflow. And obviously, the biggest part of Google's machine learning is called the Cloud Machine Learning Engine, which is the far right over here, which was made public in 2016. Many of the components are open source. Google is a great believer in open source, so we obviously want the community to benefit from all the research we do, and also want the community to participate. TensorFlow is the #2 in the GitHub open source project. Kubernetes is #1. So obviously we have a very high degree of adoption of many of the research work that we have done. And now the latest innovation is Kubeflow, which is also getting rapidly adopted. Moving on, we'll discuss a little bit about many of the models that are deployed within Google. Like if you look at the MLP stands for multi-layer perceptron, as you can see, the smaller models, which has 20 million weights and not very complex like convolutional network or LSTM, which stands for long short-term model. Those are all adopted to various degrees. As you can see, the more complex the model, the lesser the adoption, as well as even within Google, a vast amount of data is structured data. Although we do a huge number of projects with unstructured data like images, volumes, subsurface volumes, all of that. So this gives you an idea of how the adoption is going within Google. The other important project that I would love to discuss that has also been made available is called AutoML. AutoML is the ability for users to do machine learning without knowing a lot about data science. This is for people to enter machine learning without knowing a lot about machine learning algorithms or how to use machine learning. The infrastructure is all provided. You can just bring in your data. This is what we also call your data, our model. We have already created the model. You bring in the data, you train the model, and then once the model is trained with your data, you run it. So basically all the steps, the complex steps of machine learning, which is data exploration, data preparation, feature engineering, model selection, all run under the hood. Time permitting, I can even give you demos of AutoML, and also we have a simpler version called APIs, where you can take a vision image, you can load it up there, you can train it with your images, and you can easily run it. So obviously we have TensorFlow and TPUs. It will take me a long time to explain each of these. So these are all the differentiations that we can discuss. Finally, I will go through a few industry applications for AI, cloud, and mobile. And basically that highlights the speed, scale, and the customer focus that you need to have in order to succeed in this space. And here are a few key customers like Netflix, like Spotify, personalized playlist, eBay, personalized shopper. And we'll pick a couple from the different industry verticals, and we can take a few use cases. Also, we have a lot of internal use cases like YouTube recommendation engine. We can talk about that. That's about it for a teaser.
For this opportunity and giving a preview of what is coming on the very interesting AI conference in Seattle. So this is Ravi. I am the Director of Engineering as well as Operation at Kohls. So I would like to do, we'll talk about the AI and ML advancements and impact in the industry from the engineering aspect. I would also primarily also focus on what is the role of the AI and ML, what innovation and advancements that is bringing up towards the operational excellence with this new paradigms or the new buzzwords that is going across the industry, that is artificial intelligence and machine learning space. So I think the folks that have joined on this call might be expecting they have the basic understanding on what is AI. And when it comes to the operation, so as we all understand, every technology platform is transforming to the greater extent with open source technologies, microservices, and enterprise level systems integrations to whatnot. The complexity of every solution is going extremely high as the systems are getting transformed. Monitoring these systems for the real-time anomaly detection and the reaction is extremely becoming challenge. That is the new, the downside or the adverse impact of this technology advancement when a solution is totally migrated to a monolithic or running in a data center to a microservices, then cloudifying, bringing so much of operational complexity. As we all understand, the monitoring data exponentially increasing it, and the complexity of operationally managing the platform is extremely growing it. And though we have several monitoring tools, application performance monitoring and the Splunk to whatnot for the log analysis and all, they're literally dealing with the complexity of scaling up to the needs of the data that is growing from the monitoring aspect wise. So your conventional IT operations model will no longer scale where bunch of operators sitting in front of the screens and monitoring the systems to do a real-time monitoring is never going to work anymore, right? The conventional IT operations will not able to scale. And what is the way forward for the modernization of application standpoint? So at Kohls, along with AI and ML innovations, in terms of personalized experience to the customer, because we give a eventually a personalized experience from a customer to customer, and also personalized recommendations to whatnot as an engineering and functional advancements. A homegrown product, AI Ops, typically algorithmic IT operations or artificial intelligence. So this is to solve the known issues and do the real-time anomaly detection, and as well as intelligently automate the repetitive activities on the platform as well. So which we can give a deeper dive on it and a kind of a technological view and a footprint, give you a in-depth walkthrough on what is this platform, how would it work, what does it mean by it's solving the complexity and doing a proactive job and bringing the consistency on the operation standpoint. So if you look at on the challenge wise, you guys coming from an IT background, if there is an incident, if multiple people are dealing with it, you get a different answers and different inferences from different teams and different individuals. There will never be consistency between humans doing the analysis, right? That is, the consistency is always the problem. So who do I go with? If I have 10 different people or 4 different teams doing an RCA, every individual is coming up with a different perspective and different inference. What is the actual truth of behind the incident? Because there is no consistency. So that is another thing that this platform can solve by bringing the consistency. And other thing we are talking about is how we use this analytics and machine learning to analyze the heterogeneous data that is coming from the diversified sources to spot and more importantly react issues in real time. So how do we achieve is infrastructure and capacity is no longer a limit as we cloudify and have the capability to spin up not just the CPUs to the GPUs for a faster and a huge data processing standpoint, right? So to quickly go through on some of the interesting aspects, as I talked about AI Ops, this is for the real-time monitoring, real-time anomaly detection, and as well as preserve the historical learnings in the sense your system behavior at a morning 8 a.m. versus evening 6 p.m. is different. In the similarly, a high sale day versus a normal sale day is different. When there is a promotion or a campaign versus when everything is a normal is different. How would your system dynamically understand all this to consider what should be the expected consumption and behavior of my individual components in working interconnected and delivering the experience? So AI Ops is an intelligent platform which we implemented, and it is rolled out multiple phases in production, and we have actually rolled out several use cases on it, and we can have much more granular and technical deep dive on AI Ops in the conference that I will give you all a very interesting walkthrough. And we can also talk about predictive scaling. Eventually, I heard another gentleman was talking about how effectively we will manage the capacity, because cloudifying is not a luxury, right? The objective of cloudification is the capacity or the footprint of the platform has to grow organically as the traffic grows. That is the expectation. I request the folks to go on mute if they are not talking. I hear a lot of echo. So the objective of the cloudification is to get the benefit of organically scale the platform footprint as the traffic grows, right? So, but the modernized cloud providers are not that extensively providing the algorithms to achieve this. Eventually, every auto scaling, when it kicks in, when there is a CPU limit exceeded, or the TPS, or the various combinations were actually kicked in, it's not seamless. For an instance to come up and take traffic might take 3 to 5 minutes, but anything can happen in between the 3 to 5 minutes. And an instance to coming up and taking the traffic and whole activity will never work 100% seamless. Not 100% seamless. Depends on the situation to situation, how much additional traffic that actually hitting the infrastructure. But it's still reactive in the sense you're configuring your values, even though it could be low. You can ask, why not if I configure my watermarks to the lowest level? Then the purpose is defeated. In the sense you are making your platform too sensitive and you are burning out so much of infrastructure unnecessarily. What I mean here is, if 70% CPU for an auto scaling you consider as a risk, if you bring it down to 60% or 50%, you're front loading your capacity for no reason. And still it is a super reactive when the auto scaling and all the features that AWS, GCP, Azure are providing, right? Which we actually considered predictive scaling, which eventually understands the behavior and the projections of your system. The projections could be traffic, revenue, offers, promotions, your flash sales, whatnot, everything, and prepare your platform for the upcoming hours ahead of the time. If I know my platform required to scale at 6 p.m. today because the expected traffic growth on the platform is X, revenue on that hour is exponentially high, or there is a promotion which eventually allows the platform to have a lot more traffic. If that could be able to predict it ahead and made the platform scaled up seamlessly to work as a proactive, that is where we would like to go with, and which is what we have achieved through our predictive autoscaler, which is a AI and ML driven an application that I will give you a walkthrough there, which is much more interesting to see how you can basically proactively keep your platform, which is for two reasons, not just for achieving the cost benefits of managing the capacity in an optimal manner, but also to bring in the highest stability by proactively scaling and keeping your platform for next hours, next days, next weeks, next month, here now itself, in the sense you have the logic, you have the predictions, you have a way to understand what are your scaling needs or a scale down needs of your platform. This is some of the another use case, and probably I will review a few other AI and ML implementations that we have implemented in Kohls, right? So that I'm happy to share with you guys on AI and ML advancement standpoint. Also, I would like to talk about some of the use cases on the engineering standpoint where we implemented on the personalized user experience and the personalized recommendations using AI and ML. So this is as a teaser. I think I should not disclose more on this. I would like to keep this interest going on and have you guys curious about what is this all about. And I like to conclude here. And thank you so much.
Ravi,